How do you do? I'm Captain James Ferris, Commander Carrier Air Group 4. It's my privilege to welcome you aboard. The film you are about to see is concerned with two principal factors in the carrier landing equation: the pilot and the landing signal officer. The responsibility for the execution of a safe and efficient approach to landing aboard ship is divided between these two. That responsibility becomes greater each year as the unit cost of our Navy aircraft continues to spiral. We have seen great changes wrought in the aircraft carrier environment and methods of operation in recent years. Angled decks, steam catapults, constant run-out arresting gear engines, optical landing systems, swept-wing aircraft, sonic boom dives, and more recently, boom climbs. Now we see innovations like boundary layer control, automatic landing systems, and automatic power compensators coming in. All of them designed to ease the problem of bringing the airplane aboard. These devices help the pilot directly, and in so doing, they afford some additional help to the landing signal officer. But in the final analysis, he, the LSO, is on his own as he has ever been in rendering the irrevocable decision, the wave-off, or acceptance of the aircraft for landing. The landing signal officer has a unique status in carrier aviation. During my years as an active carrier pilot, I have conducted a running skirmish with many of them. But underneath the veneer of needling and jocularity and sometimes damaged pride, there has always been a heavy vein of respect for this man, this pilot, this landing signal officer. I can remember when the average LSO was the practitioner of an art as black and mysterious as alchemy itself. He needed no steeping in the laws of physics and aerodynamics. He was, as often as not, an officer with a limited span in the Navy. Some were not even aviators. Korea taught us many lessons, not the least important of which was that our supply of LSOs was short indeed. The paradox was that there was no lack of awareness on the part of senior officers to the importance of the job. We just drifted into the situation. Beginning around 1954, the first concrete steps toward establishment of a solid nucleus of LSOs composed of career officers was made. Since that time, it has been clear to any qualified observer that the ranks of LSOs in the carrier Navy today are made up of the best motivated, most skillful, and most career-minded aviators available.
There are some bad days on this job. The kind that make you wonder why you ever put in for it. And the nights can be worse. Of course, everybody has them. In the cockpit or on the ground. But there are no mosquitoes in the cockpit. There are days and nights when, as an LSO trainee, you feel that you've been miscast for the job. And maybe you should have stuck strictly to flying.
What did he do wrong?
He looked low in the groove and high at the ramp.
No, he was on glide slope, but he was using too much power. That's what caused him to go high at the ramp.
You observe, evaluate, and learn. You learn that a touchdown that is short of the landing area can be caused by dropping your nose in the groove, as well as by taking off too much power. You find that you can learn the job only as an apprentice, training for whatever number of hours are necessary to develop the judgment and temperament that will earn you the confidence of your fellow squadron members. You learn to reduce the natural human tendency to chip too much on the radio. Inexperienced pilots can become too dependent on it. Experienced pilots don't need it. No two landings are alike, just as the personalities of each pilot are different.
Roger, ball. You're a little high and a little too much power.
Eventually, you get accustomed to making instantaneous decisions until your responses become automatic. To use the few available seconds to direct, evaluate, and record.
Wave off, a little high, a little too much power. Roger, ball.
When working with new pilots, the LSO must find a way to build confidence in the man who is flying, and at the same time, maintain high standards of performance. This is reflected by our communication with less experienced pilots during practice landings.
409, paddles, over.
409, roger.
It wasn't too bad of an approach. You're having a little trouble with your starting position.
You're carrying too much power out of your turn and going high in the groove each time.
Let's move our 180 out, then you won't have to fly such a wrapped-up approach and carry all the excess power.
409, roger. By observing and correcting basic flying errors, the LSO can often help the young pilot sharpen his flying skills and sometimes build his confidence at the same time. Our debriefings of less experienced pilots follow the same logic. The debriefings are necessarily complete and quite thorough.
Seemed like the big problem out there today, and I don't have to tell you all that you weren't flying the glide slope, was your airspeed control at the start. Too much power out of your turn, late taking it off, getting fast. You get a good start, half your problem's already whipped. And Ron, today your 180 position was off. You were way too close a beam, having to carry too much power through your turn. And Tom, well, your first 3 passes were okay, but as the hop went along, the aircraft got a little lighter on you. And as you rolled into final, you were late, just a few seconds late, getting set up and taking your power off to start your rate of descent. And you got accelerating here and got fast, and also went high. And then all the way down here, you're trying to work that off, back on the power, up on the power. And finally, when you got in here close, the only way I could have gotten you down was to shoot you down. So let's watch this. We'll get aboard ship.
The thing we aim for in debriefing of less experienced pilots is to correct bad flying practices before they become habit, and before the deck gets fouled with $1 million worth of aircraft parts. All of our training, as pilots and as landing signal officers, comes into focus aboard the carrier. Here, both the pilot and LSO can be grateful for modern equipment landing aids and the coordinated action of all the highly trained deck crews. It takes some doing as aircraft get faster, heavier, and less maneuverable near the stalling speed to bring them down on an unstable deck. The margin for error is narrowing, and we need all the electronic and mechanical aids available. The angled deck itself provides for a safer landing strip, with the island and parked aircraft well out of the way. With the pilot landing aid television, or PLAT system, pilots and LSOs have a complete video and audio recording of launchings and recovery of aircraft. The PLAT system is an important landing aid to LSOs and pilots alike. On launchings, a manually operated television camera, located on the island high above the deck, videotapes each operation. Landings are also recorded by this camera, and by one of 2 television cameras mounted in the flight deck, focused up the glide path of the approaching aircraft. During recoveries, the pilot's approach is picked up by the PLAT deck cameras. His alignment and glide slope are shown by the crosshairs of the video presentation. When the hook engages the arresting cable, the controller switches to the island camera, which follows the movement of the aircraft up the deck. The complete PLAT presentation of each recovery includes the date, time, carrier number, the true approach speed of the aircraft, wave-off indicator, and wind over deck. The aircraft approach speed is obtained by the Spin 12 electronic device, operated from a platform on the island aft of Pry Fly. The Spin 12 operator keeps a radar antenna trained on the approaching aircraft as it makes its turn in the landing pattern and heads toward the carrier. Radar signals reflected from the approaching aircraft are fed into a computer and converted to a true approach speed reading. After the recovery, back in the ready room, the playback of PLAT tapes provides LSOs and pilots alike an immediate opportunity to analyze the approaches. This review provides us an invaluable aid in improving our techniques. Still another landing aid gives us additional assistance in flying the proper glide path. the Fresnel lens. The lens represents an improvement over the mirror system. Since it is more compact, it is located farther forward to allow you to see the meatball to touchdown. Brightness of the meatball can be adjusted to compensate for visibility conditions, and the lens is not affected by salt spray or sunlight reflections, as were the mirrors. The computer-controlled lens adjustment, to compensate for the ship's pitch and roll and maintain a 4-degree glide path angle, is a further contribution to precision landings. Proper hook-to-ramp clearance is quickly set by a remotely controlled roll angle adjustment. Landing aid instruments, located directly in front of the LSO's platform, include the plat presentation at the top of the panel, spin 12 aircraft approach speed indicator, relative wind direction and wind over deck velocity indicators, meatball and datum arm intensity indicators, roll angle indicator, glide slope angle indicator adjusted to a 4-degree angle, and the UHF radio control box. Your Angels have taken their positions aft on the starboard side. The carrier's speed into the wind has been adjusted to bring the wind over deck to an ideal 30 knots.
Launch aircraft. Launch complete. Stand by to recover aircraft.
Let's look at the recovery from our vantage point on the LSO's platform. The LSO and at least one assistant man the platform, wave-off switch in hand, and radio handset tuned to the land launch frequency. With the deck crew on station, we're ready to receive you on board when the air boss gives the word. Your Phantom II is in the pattern, ready to make the approach turn.
Give the backwash at Charlie now. Set the gear for Phantom.
The air boss has cleared you for landing. Lens and arresting gear settings for your type aircraft are being made and checked. Upon completing the turn onto final, you have about a mile, or 20 to 25 seconds, to establish your angle of attack, line up and center the meatball for an okay approach. You're rolling out in the groove. Last check. All down. Get that donut on the indexer and hold it. There's the meatball.
104 meatball.
Roger, ball.
Get the meatball centered. Check the lineup. Donut. Meatball. Keep it going. You're on the money with number 3 wire. Because time could be the most critical factor in accomplishing recoveries in a wartime mission, our techniques include closely monitoring the interval between aircraft in the recovery pattern. We have found that a closely monitored pattern improves air discipline and airmanship and results in a smartly executed recovery. Since it only takes one man to completely disrupt an entire recovery pattern, we monitor his turning point as well as his altitude. Many of the corrections required on the glide slope are the direct result of errors made earlier in the approach. In judging correct power settings on the approach, we depend on both sight and sound. For instance, some engines have a characteristic pitch, like the sound of the F-4 Phantom. When the Phantom is coming in with too much power, the engine pitch will be higher. When the power is too low, the sound will have a distinctively lower pitch. We notice the jet exhaust smoke. It increases as power is added. It decreases as power is taken off. We also learn to make instantaneous judgment by the configuration of various aircraft as seen from the platform. There's a speed gauge for each aircraft. For example, on the A4, The axle of the nose wheel should be in line with the bottom edge of the flaps. If the axle is above this, he's slow. If it's below it, he's fast. For the Phantom II, the nose wheel, as seen from the platform, should be in line with the auxiliary air doors. If the nose wheel is above this location, he's slow, and the leading edge of the stabilator may be damaged by the arresting wire. Sooner or later in a group recovery, you can count on us to hit that wave-off button.
Wave off, foul deck. Wave off, foul deck.
Just when you're right in the groove and set up for a perfect landing. Most of our problems, however, are like those of a nightclub hostess. They begin to accumulate after sundown. At night, you've lost most of your visual references and your depth perception, and must rely on flight deck lights, your instruments, and landing aids. At the same time, we on the platform must adjust our techniques. In daytime, we're accustomed to judging the glide slope with reference to the horizon. At night, we use such references as the truck lights of the destroyer stationed astern. Since we do not have the attitude references based on aircraft configuration, we must rely on what we can see, the exterior lights from your aircraft and your approach lights. They provide an indication of your approach speed, which can be cross-checked with spin 12. Location of your aircraft lights during the approach can also aid the experienced LSO in judging your speed and attitude. For example, on the A1, we should be able to see the white tail light during your approach. If it is not visible, you're probably too slow. On the S2, the two red lights should appear as one during the approach. If there is a separation between the two, he is slow. In landing all prop aircraft, the pilot's lack of depth perception at night presents a problem of when to flare the aircraft after the cut for a good three-point landing.
A little more power. Cut.
Nearly always in a night recovery, you get more wave-offs. And we can expect an occasional boulder as the result of a hook skip or an approach that's too high. As always, after each group recovery, day or night, comes those jolly sessions known as the squadron debriefings by the LSO. Remember, in daytime debriefings, the Platt videotape presentation provides the precise details of each recovery, thus eliminating the necessity for the LSO to make detailed comments on most recoveries. On night recovery debriefings, the observations and evaluations rest with the LSO.
Okay, who had 302?
I have.
Beck? It was a fair pass. You had a high start, went to a low in the groove, a little low at the ramp on number 1 wire. In correcting for your high start when you were working the ball back to the center, you didn't stop it soon enough. You've got to lead that correction and come on with power so you don't go low. We'll give you a fair on that one. 311 was Ingham. Okay on your first pass, but I had to give you a foul deck wave off. Second pass was fair, not enough power in the groove, and you settle to a low. As soon as you see the ball going low, you want to come on with that power and get that ball centered. You're waiting too long to get it centered.
Yeah, well, I got about halfway down the glide slope, and it looked like the ball started to get dim.
Well, yeah, the ship was putting out a little smoke at that time, and it was going across the groove. That's probably why it looked a little dim.
There are bound to be some bruised egos resulting from debriefings, but when they're businesslike and impersonal, the experienced pilot takes his criticism in stride. The situation where the LSO-pilot relationship becomes more personal can happen suddenly during an emergency.
Back in that stick and try and get that tail down into the area. Just fly a normal approach until then, though. Little bit of power. Keep up there. I'll rig the barricade.
Here, the pilot and the LSO work together even more closely as a team.
1-2, this is paddles again. Don't get hypnotized with looking at this barricade. Now keep that normal scan going. That's the only way you can guarantee yourself a successful engagement.
Ours 612, Alpha 5, about 1,500 pounds, Ball.
Roger, Ball. You're looking real good. You got a center ball now? All right, don't get low or slow now. Keep that power on. You're looking good. Don't go high. You're looking real good. Hang in there. Hold it up to the air. That's good. You're looking good. Now, cut.
The landing signal officer is proud of his job and the confidence and support he receives from his command. We find there's a special dividend in the job in terms of personal satisfaction. But there's a plus factor in the LSO job that makes it attractive to most of us. We like to fly, and we're encouraged to fly several types of aircraft. Many LSOs fly 3 or 4. We believe our LSO duties help to make us better pilots.
I've said that the LSO enjoys a unique status in our Corps. Show me an officer with Lieutenant JG or Lieutenant stripes whose approval is sought by every squadron pilot. Show me a young officer to whom squadron commanders and air group commanders level a particular kind of deference and to whom skippers listen with concentration. Show me a back a little bit straighter, an eye more clear, and a sunburn more pronounced than most, and I'll show you a landing signal officer, an all-important cog in the great machine that is carrier aviation. During my years as an active carrier pilot, I have conducted a running skirmish with many of them. But underneath the veneer of needling and jocularity and sometimes damaged pride, there has always been a heavy vein of respect for this man, this pilot, this landing signal officer. I can remember when the average LSO was the practitioner of an art as black and mysterious as alchemy itself. He needed no steeping in the laws of physics and aerodynamics. He was, as often as not, an officer with a limited span in the Navy. Some were not even aviators. How do you do? I'm Captain James Ferris, Commander Carrier Air Group 4. It's my privilege to welcome you aboard. The film you are about to see is concerned with two principal factors in the carrier landing equation. Now we see innovations like boundary layer control, automatic landing systems, and automatic power compensators coming in. All of them designed to ease the problem of bringing the airplane aboard. These devices help the pilot directly, and in so doing, they afford some additional help to the landing signal officer. But in the final analysis, he, the LSO, is on his own as he has ever been in rendering the irrevocable decision, the wave-off, or acceptance of the aircraft for landing. The landing signal officer has a unique status in carrier aviation: the pilot and the landing signal officer. The responsibility for the execution of a safe and efficient approach to landing aboard ship is divided between these two. That responsibility becomes greater each year as the unit cost of our Navy aircraft continues to spiral. We have seen great changes wrought in the aircraft carrier environment and methods of operation in recent years. Angled decks, steam catapults, constant run-out arresting gear engines, optical landing systems, swept-wing aircraft, sonic boom dives, and more recently, boom climbs. Korea taught us many lessons, not the least important of which was that our supply of LSOs was short indeed. The paradox was that there was no lack of awareness on the part of senior officers to the importance of the job. We just drifted into the situation. Beginning around 1954, the first concrete steps toward establishment of a solid nucleus of LSOs composed of career officers was made. Since that time, it has been clear to any qualified observer that the ranks of LSOs in the carrier Navy today are made up of